Now we'll be talking about trends across the periodic table. The first trend I want to talk about is atomic size or atomic radius. So there are two trends in this. The first is as you go from right to left, the atoms get bigger, and as you go up to down, the atoms also get bigger. This is for two reasons. The first is as you go down, you get more shells. This is more volume occupied by electrons. This also leads to a decrease in the attractive force because electrons on the outside aren't as attracted to the nucleus because of a greater distance. The greater the difference between a negative charge and a positive charge, the less the force, and so there's less of a crunching effect. This is also due to shielding, which we'll get to in a second. The next thing is a greater charge difference. So as you go left to right, there's a greater charge difference causing more of a crunch for atoms on the right hand side. So if we take a look at lithium, we have 3 protons and 3 electrons. This causes a charge difference of 6, whereas fluorine has 9 protons and 9 electrons, a charge difference of 18. 9 positive, 9 negative, 18 difference, 3 positive, 3 negative, a 6 charge difference. Because fluorine has a larger charge difference, there's a greater discrepancy between the positive charges and negative charges, so it's going to crunch more. Whereas lithium has 3 positive charges and 3 negative charges, it's going to crunch less. The next trend is ionization energy. Ionization energy is defined as the energy required to remove one electron from the outermost shell. It gets greater as you go from left to right, and also as you go down to up. So the reason it gets greater as you go up is because you have less electron shells, so there's less shielding, and it's more difficult to remove one electron. We'll get to that in a second as well. Number 2, it increases as you go to the right, since nonmetals like to gain electrons. So shielding. So shielding is a decreased attraction between an electron and the nucleus due to the presence of other electrons between the electron in the outer shell and the nucleus. Imagine it as one person standing outside looking at a light. The light is the nucleus and the person outside is the electron. There are many people walking between that person and the light. The person standing outside isn't going to see the light as much. The light being the attractive force felt by the electron to the nucleus. If there are many electrons in the way, the electron standing on the outside, the valence electron or the outermost electron, isn't going to see the light or the attractive force as well as it would if there weren't electrons in the way. The last trend is electron affinity, defined as the energy released when one electron is added. This is a bit more of an irregular pattern, but there is some trend. It increases as you go to the right along the periodic table, and also as you go up along the periodic table. The only thing you guys really have to know is that metals have lower electron affinities, and nonmetals tend to have higher electron affinities.